Hello, I'm back. I'm pretty excited about doing this this particular video. It's the very first video I've done that was prompted by a comment, and we're going to be talking just really briefly about the difference between API mode and AT mode or transparent mode using the XBee radios. So was it Luis Zamora was asking about AT mode versus API mode? How do they work, and how do you get more velocity out of the radios? So I figured it'd be nice to just kind of go through some of the basics because this is something that absolutely confused me. And I'm the type of person who really needs a lot of hand holding and that minute detail when I'm first learning something. So I've already climbed that learning curve, and I'd love to just pass it along to you. So let's get in here, and what we have is we have XCTU set up, and I have 3 different radios over here on the side already connected. These are all 3 in transparent mode, and I've named them coordinator, remote, and remote. Now, if you don't know what those are, go check out one of my other videos about how to get started with XCTU. But basically, the coordinator is going to be kind of the boss. So what I'm going to do, and this is interesting here. I've got these things broken out, like this remote 1 right there. So take a look. Oops, check on something. There it is. Okay, cool. So what you can do to break these out is when you're looking at your console view, you're going back and forth, as you can see, between coordinator, remote. If you want to see everything, just click on one of the radios and click this detach button, and it'll pop it out. I popped it on my other screen over there, but there we go. So I like to, when I'm messing with lots of them, just kind of have these up here. All right, so what we're going to do is we're going to open up the ports so we can start talking to each other. And get my notes here so I can go through it really quickly for you. So first of all, what we want to do is take a look at what is transparent mode, because they're all set up in transparent mode. So first of all, what you can do when you're in transparent mode in these console logs, you might have this little view here that has a window. You can just type in, hello world, right? And so this is the coordinator. Now what transparent mode does is it's really just what you see is what you get. Whatever you type or send from a radio, it's just transmitted just in those little bit packages, those hex values, and that's what we see over here. And as I did it from the coordinator, you can see that when I type 1, blue is what was sent, red is what was received on the coordinator. Now this isn't making a whole lot of sense when we're just talking about the coordinator, because you see I have these remote radios set up as well. But let's go over to remote 1, and let's type in hello. Oh, notice I can't backspace, from remote 1, right? So as I typed over here in remote 1, as every single character, every single keystroke was sent individually through, wirelessly from the remote 1 radio over to the coordinator. Well, it was just sent out there, but because the remote radios are connected to the coordinator on the same network, the coordinator is receiving it. That's really what's happening. So I can just keep doing this, I send 1 and it comes in immediately. Now you'll notice remote 2, I can do the same thing down here. Remote 2, do hello from remote 2. Now what's interesting is remote 2, it sent it out, the coordinator received it, but you notice remote 1, the other radio, they're both on the same network, but they can't talk to each other. There's really just no way to make these two talk to each other using transparent mode. Transparent mode is dead simple. It's just what you see is what you get, right? So something I want to show you here is this. I don't know if you know about this option. You can actually, we can look at the hex code here, right? We can see what was sent in blue and what was received in red. And this is, believe it or not, this is the pretty way of looking at it, right? We can actually save the console session, and I'm going to put it up here on my desktop. This is going to be from the, actually, you know what I'm going to do? I'm going to clear this out and do it from scratch so we can take, there we go, cool. What I'm going to do is type hello from remote 1. That's all we're going to need. So I'm going to save this from the coordinator. There we go. And I'm going to save the console log from the remote 1. There we go. I'm going to go over here and open those up. There we go, desktop. That's on my other screen. Coordinator and remote 1. All right, so this is what those console sessions look like. Or this is actually what the this is what's happening between the radios, right? So the console session is just a way to save things. We can see here on the left, this is from the coordinator, and we have all of this, a little bit of data about the coordinator. And you notice all of this is what you see over here. So we know that this is a console from the coordinator. We know its baud rate. We know its node identifier, things like that. But each one of the, you notice like each one of these lines is time stamped, right? And this is, you know, kind of a frame ID as we start talking about API mode. So it received 68, then it received 65 and received 6C. So that was HELLO. So every single character is sent individually. There's no concept really of these strings of characters, okay? And we can say that it was received. We can see that this data was received at this time. So there's some value there. If we look on the remote, it's exactly the same thing. If I can, whoops, just hit it from myself. Where'd it go? There we go, remote. We can see the same thing from the remote. All the sort of metadata about the radio. And then we can see this at this time, this data was sent, each and every one. But this is how the radios view things. It's really just a serial connection. That's kind of how you treat it. So what are what's this good for? Well, why would you use this? It's easy. It's not complicated in any way. You don't have to worry about things like frames. You can see that I just, you get in there and you just type stuff and it starts showing up in the coordinator. Now the drawback is, this is just raw data. If you want to do something with this data over here on the coordinator side, if your coordinator is hooked up to something like to an Arduino or a Raspberry Pi or your computer, you have to parse this out. You have to make sense of what this data is, right? You have to figure out sort of protocols, if you will, about where did it come from, what does it mean. All right, so it's easy, but that's also kind of a drawback for it. Now, Louise was asking about throughput. Well, this is, you can put a lot of stuff through it. I went and generated this 500 paragraph IPSM. All right, I'm just going to go ahead and copy this. There's a lot of data here. And what I'm going to do is, just as a demo, I'm just going to paste this in remote 1 and just watch how quickly this is coming over. Boom. So as it's being pasted in, it's being sent over, and we can see how many bytes are coming through. There we go. Yep, 13,784, so what, 38K just went over. That's how long it takes to get 38K over. So yeah, if you're just trying to put masses of data between 2 points, and you don't really care where the data came from, and you know how to parse it on the other end, yeah, this could be a really quick way to get up and running with the radios. Just you're treating it like a serial port. All right, so what I'm going to do is I'm going to pause this for just a second, and I'm going to get set up and show you API mode. I'll do it with 1. I'll show you how to change these over, but then I'm going to pause it because it does take a minute. So first of all, you select your radio. I'm going to do the coordinator. Right, and so we get this view. You guys have seen this before. We still want this to form a network. I'm going to go to AP, which is the API configuration down here, and it's in AP mode 0. I'm going to change it to API mode 2. No escapes. Write that, and this is going to turn into AP mode. There it is. Boom, just like that. Now the challenge is, I think, that when I go back over here, oh, I do get frames there, so that might be nice. All right, cool. So I'm going to pause this here, and I'll be right back. Okay, I'm back. I've got everything set up in API mode now. There's something I wanted to show you just in case you're taking a look and being a little confused by it. This PAN ID right here, this is the network that I have, the coordinator, the network ID I'm using for the coordinator. You don't have to put anything in here. You should probably, especially for the coordinator, but you don't necessarily need to do it for the remote devices. We'll look at remote 2 up here, and you'll see that I put the 2, 3, 4, 6 in there as well. The reason I do this is I'm forcing these 3 radios onto the same network. And if you're only using 3 radios, you really only need to set that for the coordinator. The remote radios will just find it as long as you've kept everything on default. But I have several networks running in here in the office right now, so I want to go ahead and force that. That's what's going on there, in case anybody was wondering. All right, we're going to switch this over to console view. I'm going to go ahead and detach these. Whoops. There we go. We'll put remote 2 at the top this time. Fine. Remote 1. We're going to detach it, and we'll be able to take a look at things. All right, so API mode is fundamentally, you're using these frames. Okay, you have to understand the concept of the frames within for API mode. So what's a frame? A frame is just a really specifically configured hex string. It's a protocol, if you will, so that you can send. It sends metadata and a payload. Those aren't exactly the terms that XBee uses, but I like to think about it that way. So if I'm over here, say in remote 2, so I have this little, let's say I have a sensor over here. I want to send some information to the coordinator, right? I picked up some data and I want to send it over to my coordinator to have some processing. Well, there's no way in here, you can hear me clicking, there's no way to just type it in. You have to actually configure what you're doing. So I'm going to do I'm just going to transmit a hello world, right? So what I'm going to do here is I'm going to generate a frame. And XCTU has this really nice tool, the frame generator. And there's a lot of stuff going on here. I'm not going to go in detail about it, just to say that there's API mode is powerful and you can do a lot of things with it. The things that you'll probably do most are AT commands, remote AT commands, and transmit requests, right? Anything beyond that is really some power user stuff. So I'm just going to use a transmit request. And transmit is exactly what we were doing in transparent mode. We were just sending data out. When you're creating a frame for API mode, there's all kinds of stuff up here. 10 is the frame type. What's most important here is this destination address. So in API mode, you have to put an address in there. You have to tell the message where it's going, right? Now, by default, the zeros show up in the frame generator, and 0 is the default address for the coordinator of a network. So if you have a remote device, just keep zeros in here, and whatever we put down here in the data section will just be transmitted to the coordinator. And I'll show you how to do explicit addressing here in a second. So what I'm going to do here is hello from remote 2, right? So that's our address. This is the data we're sending, and that's all we really need to do. I mean, it's that simple to generate a frame. Now, what's going to be sent, actually, is all of this. This is the hex string that's being sent, and you can kind of notice if we pick out there, you can suss it out. There's delimiters. That's an important thing. It gives you the length of the frame. This is the frame type, the ID. Here's the address. You can tell, right? Now, we don't see this hello from remote, but we can see it. It's hex string, so it starts at 48, goes to 32. So we can just pick that out right there, can't we? So what's interesting when you're using API mode is you're sending all of this extra information along with the payload. If we were in transparent mode, that's all we'd be sending, and that's all you'd get. So this extra metadata is really, really powerful. All right, so we've created a frame, and let's add that over here. And so if we want to use this in XCTU, you select the frame you want to send, and then you can just send the selected frame. Now you'll notice over here, and we transmitted it, we have a status message, and over here we have a packet. There's a lot more information going on. So in API mode, I'll make this really big so we can see, look at all this information we get just about sending the message. So we see the hex string that was sent. This is all the information that we saw in the frame generator, right? And then after we sent it, we actually got this receipt back. And this is really powerful. This is where, if you're starting to set up, more than 2 radios, you really got to use API mode, because you'll get a status message. You'll see down here where it says delivery status success, right? So if you put the wrong address in, if the radio you were sending it to was down for some reason, you'll get a fail message and a reason, so you can start diagnosing those problems. So that's really, really good. Also, we'll go take a look over here at the coordinator. Let's look at the message that was received, right? So, whoops. So this is the packet that was received. That's a frame type of 90, so we can do lots of stuff with it. Now what's really interesting, now what came inside this packet is the address of the radio that sent the message. Now this is great. So when you're building out a network, as you're starting to program and use these things in a real world application, it's really good to know where the message came from. So if I have a remote radio over here that's sending in some sensor data, and the data goes above or below a threshold, what I can do is we can tag this data to saying it came from this radio, which is a proxy for this sensor, and then we can send the data, like some commands back to that sensor to do something with it. So anyway, knowing where things came from is really good. That's all. And this is the packet you receive. That's pretty cool. Now we can do that. That's just transmitting. And you remember when we were doing transparent mode, we couldn't send between these 2 remote devices, right? Well, in API mode you can, as long as they're on the same network. So we're going to do a new one. Let's create another frame called TX2 remote 1. And by the way, this right here frame name is just for this app. It has nothing to do with the frame itself. It's just so we can keep things straight. So we're going to transmit over to this remote 1. Now we need to get its address, and we can get it a couple places. I've got it covered up there, but I do have it down here. Its MAC address there is the same thing. So I'm going to type that in, 0013A20041982A30. Cool. Don't worry about the 16-bit address. I find it to be better just to use a 16-bit address all the time. I don't know if there's actually a benefit to using just 16, but it's more advanced. Let me just hush. Hello, remote 1. This is remote 2, right? There we go. And so you see we got a lot of bytes going in there. And I don't know if you noticed how, as we add things in, whoops, there we go. As we started, as we add stuff or delete stuff, the checksum is changing, the length is changing. So this generator is doing this really specifically configured hex string. There we go. So we're going to go ahead and save that frame over here. We're going to add it to our list of things we can send, and now we're going to send it. And cool, we can see immediately it showed up over here on remote 1. And we have the same thing. We have the transmit request in our console. We have the status. You can scroll down and see the status. We can tell where it went. Successful. And so this is really cool if you want to just send direct messages between any radios that are on a network. You can do that as long as you know their address. Let's come over here to, because we've left out the coordinator. The coordinator obviously can just send direct messages back to each of the radios. The configuration of the frame is going to look just like we did here, remote 2 to remote 1, where you have to put explicitly the address in there. But it's got this other neat thing you can do, not just for the coordinator, but all of them. I'm going to show you a different type. You've got this, I forgot the frame type. It's a broadcast, right? So where'd it go? Well, I might just cut this out if I can't find it. Anyway, there's a way to broadcast lots of stuff. So I'm going to go ahead and skip over to AT commands, right? So this is something that's really neat. So you can use AT commands. I'm not going to go into it right now. But in serial mode, you can actually enter transparent mode. You can enter the command mode, and you can make call AT commands on the specific device you're connected to. Well, in API mode, you have this concept. You can do remote AT commands. So what I'm going to do here is I'm going to go over here to remote 2, and I want to get some information about it. So I'm going to put in its address, BBBE44. There we go. And the way we configure this is, first thing we have to do is put the command in. And what I want to know is its NI, its node identifier. And that's it. So I'm just asking, hey, what is your node identifier? Your node identifier, by the way, is just its name right here. Okay. So I'm going to click OK, click Add Frame. I'm going to send this frame. You'll notice nothing happened over here. We didn't get anything logged necessarily on remote 2 because this was really a kind of, it's an AT command. It's just asking for some configuration information. So this is the request that we sent, and here's the response. And we can see its response is 4E49, right? You know what? I think NI is the wrong one. Let me go over here and remote 2 is. So that's cool. So I can read data from it, but I can also change data. I'm going to try another one here. We're going to do a remote AT command, and we're going to change the name of remote 2 to remote something else. So let's do a remote AT command. Let's pop it in there again. 0013A 2004 BBB Echo 44. Cool. I'm going to change its name to something different called remote test, like that. Boom. I'm going to add that frame. And so now what I'm doing, I'm not just going to get the information from it, I'm actually going to change what's going on. Let's see what we did. That's our request. We changed the parameter to remote test, and our response is status OK. So if we reloaded remote 2, let me go ahead and do that real quick. That's on COM4. Cool. This is the best way I know to update it over here to see it, to be honest. That's the only reason I'm doing it this way. Yeah, see, it says remote test now. Cool. So now we have a, where'd it go? Oh, it's over there. Yeah, so I was able to actually change the configuration of a radio remotely. That was all done over the air. It wasn't done through the console and direct communication. So that's really cool. Well, what we want to do here, let's go. Uh-oh. Oh, I got myself in a bit of a pickle there, didn't I? There we go, coordinator. All right, one last thing on API mode, right? So remember we have this console. I'm just going to go ahead and save this console here. It's a coordinator API mode API console session. Cool. Let's pick this up. There we go. Yeah. So this is way different than the coordinator in transparent mode. You can see all of the extra information that you get. So each one of these lines is a message. So it's a frame, I'm sorry. Each one of these lines in API mode is a frame. So you see we have very similar information. We still have the timestamp, and we say it was received, and we have a frame ID and things like that. So everything from here over is exactly the same between API mode and transparent mode. But then we have this entire we have the whole hex string. Now there's ways to decode this, and that's really what your programming libraries are for. The ones for Android and for Raspberry Pi, or Python. Sorry, not Raspberry Pi, but let's be honest, most people are going to use it on Raspberry Pi. So when you're using the libraries, what they do, these libraries help you very easily and quickly parse out the data and the information that's in here, so that you can see length, frame type, ID, command. You can see RF data. You can get access to all these really quickly and very easily inside the library. You can send various different types of frames, like that remote AT command. Anyway, lots and lots of metadata. So why do you use API mode? Really, it's just way more powerful. That's really all there is to it. And if you're going to have a network that has more than 2 or maybe 3, like more than just a really basic, simple network, you have to use API mode. If you're going to be controlling if you're going to be using MicroPython, or you're going to be using some other computer and hook the XBee to it, you have to be using API mode. The drawback, if you will, is that there's a little bit of a steep learning curve to it. There's a lot to it because it's so powerful. But if you just stick to some of the basics, just learn how to transmit, learn how to receive, learn how to change some configurations using those AT commands, it's great. It's so easy to do. And I'll be doing some videos on getting started, programming with MicroPython, how to connect it to an Arduino. And in those, I'll never use transparent mode. We're going to be using API mode the whole time. So that's it. That's all I have. If you have any questions, let me know. Sorry this went really long, but I had a good time, and I'll see you next time.